Welcome back, students. Myself Sir Sunil, your chemistry teacher. In 8th class we are discussing the third unit, elements, compounds and mixtures. From this chapter we are going to discuss today an important topic, mixtures. Okay students, all of you please take out your book and ready to watch the video carefully. Okay students, here is our topic, mixture. Elements and compounds we have discussed. Element cannot be split by chemical method or a physical method, okay, but compounds can be split by chemical method but not by the physical method. Then what is the definition of mixture here? Clear? What is the definition of mixture here we are going to discuss? Elements and compounds, they are generally mixed with other. Elements and compounds sometimes mixed together. For example, air contains the elements nitrogen, oxygen and the noble gas. Air is a mixture, and also in air elements are there, nitrogen, oxygen and noble gases. And same time compounds also mixed in air, which are the carbon dioxide, okay, carbon dioxide and water vapor are contains in these both contains in air. So air is a mixture of what? Elements and compounds. And natural water contains dissolved air and some salts, dissolved air, some salts, chlorides, sulfates and hydrates, hydrogen carbonates contains in natural water. Okay students. Similarly, seawater contains so many dissolved substances that it is unfit for industrial, agricultural and domestic purposes. Sea water, vast area we can see the water in sea, but we cannot use for industrial, agricultural or domestic purposes. Why? It contains too many dissolved salts. Thus, these substances are impure and are called mixtures. Air is a mixture of gases, different types of gases, and seawater contains too many salts. Okay, that's why these substances are impure and are called mixtures. The different pure substances which a mixture is made up of are called the components. The constituents contains in a mixture, the elements or compounds contains in a mixture is called components of the mixture. These components can be separated by simple physical method. So here is a definition for the mixture. Okay, the definition of elements and compounds, please remind now, please keep in your mind, and compare that definitions to the mixture's definition. Here is the definition: a mixture is a substance which can be split into two or more pure substances by a physical means. Clear? Elements and compounds, these both cannot be split by the physical method, but here mixtures can be separated by the physical method, such as filtration, sublimation and distillation. Clear students? Now we are going to discuss about examples of mixtures. Most substances we come across in nature are mixtures. Human beings have also made many useful mixtures. Some examples are given below. Air is the most commonly found mixture in nature. We have discussed at present. Just now only we have discussed about the air. It contains nitrogen, oxygen, noble gas, carbon dioxide and moisture. We can separate the components by the physical means mentioned above. We can separate the components by the physical method. Natural water, that is also we have discussed. It is a mixture containing water, dissolved air and some salt which can be separated by physical method. Another one, foodstuff. Example, rice, wheat, pulses, vegetables, fruits, milk, butter, meat and fish are all mixtures, are all examples of mixtures. They contain substances like starch, proteins, vitamins, salts, sugars and water in different proportions. This all contains different types of proteins, vitamins, sugar, salts, etc. in different proportions. Medicines which we are using to cure the diseases. These are also examples of mixtures. These mixtures, medicines are mixtures containing some active ingredients in minute quantities mixed with some other substances. The purpose of adding some other substances is to lessen the harshness of the chemical activity of the active ingredients. At the same time, the bulk increases and it becomes easier to dispense the medicine. Next one, alloys. Alloy is a mixture. Alloys are very common examples of mixtures. It has been found that a metal when alloyed with other metal or non-metals is generally more useful than the original metal. It is more strengthened than the original metal. Mixing up of metals or non-metals, we are making the alloy. We are making an alloy. This alloy is most useful and more strengthened than the original metal. For example, steel. Steel containing iron, carbon and manganese. Or stainless steel containing iron, chromium and nickel. These both are more useful than iron. Steel and stainless steel. These are more useful than iron. And so are brass. Brass containing copper and tin. It is also more useful than copper. Also gold is generally mixed with silver and copper. The alloy is tougher than the original metal. Gold is a soft metal. But by adding silver into it or copper into it, it will become a strengthened metal. Now, industrial materials like cement and glass are mixtures of silicates and metals. Cement is a mixture of calcium silicate and aluminum silicate, and glass that of sodium silicate, potassium silicate and lead silicate. Cement is a mixture of many substances, many chemicals. All minerals are mixtures. All minerals are mixtures. So we have discussed many examples here. Many examples for the mixtures. Now we are going to discuss about the characteristics of a mixture. First property it is, the components of a mixture may be present in it any proportion. For the components there is not a particular ratio. There is no condition, there is no boundary that this much components only can be occupied. No. The components of a mixture may be present in the mixture in any proportion. For example, regardless of whether you dissolve 1 or 2 spoons of sugar in a glass of water, the resulting solution will be a sugar-water mixture. Again, air, a gaseous mixture, contains more carbon dioxide in cities than the countryside. Then the rural side, in cities, carbon dioxide, the amount of carbon dioxide in the air, that is little more. Also, moisture content of air is greater during the rains than in dry season. So in these examples, the constituents, the amount of constituents contains in a mixture, that varies. Second property, that is the components of a mixture coexist without chemically reacting with one another. For example, nitrogen, oxygen, carbon dioxide, noble gases and moisture coexist in air as they are and do not react among themselves to form any new substances. Similarly, water does not react with the soil in mud, with sugar in a sweet drink. Now, third property, the components of a mixture retain their properties. It does not change its property. The components of a mixture, it retain its property. It does not change the property. The constituent elements of a compound do not retain their properties, but the components of a mixture do. For example, hydrogen and oxygen do not show their properties in water. We know that hydrogen is a gas and oxygen also a gas, but by mixing and kindling it, we are getting one compound, that is water. It's a liquid, not a gas. But water and sugar do in a sugar solution. Isn't a sugar solution sweet as well as watery? Yes, sugar is sweet only, always. If you mix in water, the water full solution will change as sweetie. Now, the components of a mixture can be separated by simple physical method. The components of a mixture can be separated by physical method. By simple physical method, we mean here methods like filtration, sublimation or distillation, etc. By these methods, we can separate the components of a mixture. Okay, students, now we can discuss the topic types of mixtures. Okay. Mixtures are usually classified on the basis of the state of their components. A mixture containing two or more solids is called a solid mixture. A mixture containing two or more solids is called a solid mixture. Two or more liquids called a liquid mixture. Two or more gases called a gaseous mixture. And beside these mixtures, we can have solid liquid, liquid gas or solid gas mixtures too. Okay, students, different types of mixtures are there. Okay, now one more important point. There are other two types of mixtures also: homogeneous and heterogeneous. Homogeneous mixture means a mixture which has the same composition and properties throughout is called homogeneous mixture. It shows the same composition throughout the solution. And what is heterogeneous? A mixture which has a different compositions and properties in different parts of it is said to be heterogeneous. The particles can separately seen in heterogeneous mixture, but in homogeneous mixture the substances cannot be seen separately. One can see separately or distinguish between the different components of a heterogeneous mixture, but not in a homogeneous mixture. We cannot separate it in homogeneous mixture. Examples here you see namkeen. Which type of mixture it is? Homogeneous or heterogeneous? Of course, we can say that it is a heterogeneous mixture because every ingredients can be separately seen here. Okay, see, nuts are there. Clear? Everything can be separately seen here. That's why it is a heterogeneous mixture. Now, you see Coca-Cola. Which type of mixture it is? Can you see separately the ingredients from it? No, we cannot see. So, this is a good example of homogeneous mixture. Thus, A fizzy drink that contains carbon dioxide, water and sweetener in the same proportion throughout is a homogeneous mixture. But an oil water mixture is a heterogeneous mixture. Table 3.2 lists various kinds of mixtures. In solid, you see, all alloys are homogeneous. Brass, steel and stainless steel are all homogeneous. But heterogeneous, sand plus salt, salt plus pepper, chalk and sugar, these are all heterogeneous mixture, we can see separately. Now liquid case, a solution of spirit in water, that is a homogeneous mixture, and same time oil and water, that is a heterogeneous mixture. Okay students, now gaseous mixture, here all mixtures of gases are homogeneous, you cannot see separately. Solid liquid, a solution of salt or sugar in water, that is a homogeneous mixture. Sand plus water, chalk plus water, heterogeneous. Solid gas, smoke is a good example of heterogeneous. And liquid gas, dissolved air in water, fizzy drinks, homogeneous. Clear? And mist, example of heterogeneous. Okay students, go through the table once again. Okay, and now we are going to discuss the topic separating the components of mixtures. So now it's time to wind up the class. This point will be discussed tomorrow, and students, you have to complete the copy work. 2 units already completed. Okay, yesterday I told you, I reminded you to complete the copy work and also learn the question answers. Learn the question answers and keep. It will be easy for you for the examinations. Okay students, now we can wind up this class. Thank you and have a nice day.